So in this video, we're going to talk about going backwards and finding what we call the inverse normal for a normal distribution. And what you've done so far is that everything you've done, I've given you some kind of probability, or I've always given you a score and told you to find a probability. So you found a probability that corresponded to a score so far. We're going to reverse the process now. And instead of giving you a score, I want you to give me the probability, or what we also refer to as the area for I want you to give me the specific score to the area if I give you the area. That area that we're going to use is going to be known as a percentile. And you already know percentiles. We've talked about them before, but a percentile measures the area that falls at or below a specified value. The one that you know the best right now is the median. And the median area that falls, remember, at or below looks like this. The median represents the 50th percentile. And when we talk about percentile, what we're really talking about is what we call our left tail area. So you're always looking at left tail area for these problems. And when we do this, this left tail area is going to always be expressed as a decimal when we go to Desmos. So here's how this works. We're going to use a new function called the inverse. The inverse means go backwards. We're going to put in it the normal parameters that we normally have, and then we're going to have this left tail area. So let's look at this example. Scores for police training tests are normally distributed. Remember, this normally distributed means I can draw a normal curve. So I'm going to draw a normal curve. And I'm going to label this normal curve with the mean, that is 50 at the middle, and a standard deviation of 10. So that's 40 on this side, 60 on this side. This says an agency will only hire applicants with scores in the top 10%. So in order to be hired by this agency, you have to score in the top 10%. Well, I know that the 50th percentile sits here. That's the 50th percentile. If I'm in the top 10, I must be doing better than the 50th percentile. So that means I'm going to fall on the right-hand side of the median. And that also means that the top 10 percentile is going to fall somewhere out here. And if I'm better than the top 10, that means I'm also to the right of this value right there. So this is the value I'm looking for, and this represents the top 10%. Now, there's a problem with this. And the problem is that, remember, when we use this function, right, we can only find left tail area. Well, this is right tail area. It just so happens, though, that the percentile can correspond to two different values, or it actually corresponds to one, but we're looking at the left-hand side of this. So if this is the top 10%, then this represents the bottom 90%. So that means I'm looking, the top 10% corresponds to the 90th percentile. So I'm going to find the 90th percentile for this particular problem. All right. So in order to do that, I'm going to use the inverse function of going backwards. I've given you a percentage. And inside that, I'm going to nest the normal function, the normal distribution, with its mean and its standard deviation. And then I'm going to I'm going to find the left tail area, which is the 90th percentile. So in this case, it would be 0.90 as a decimal. So here's what we have. We go to functions. The inverse function is located where your other functions are in the distributions. So it's inverse CDF. Nest inside of there the normal function. Give the parameters of the normal, 50 and 10. comma, and then give me the left tail area, 0.9. When I do that, I see that my x here is equal to 62.8. And that value corresponds to something out here that makes sense. And we can see that it makes sense because we know it has to be bigger than the median, in this case is 50. And that's sitting somewhere on the right-hand side, so that's 62.8. Let's say instead of changing it to 90%, we actually did the 10%. Well, here's what would happen. If you change that left tail area to 10%, notice you get 37.2. That's somewhere on this side. That's because it's calculating the bottom 10%. That's because the bottom 10% is the percentile, the 10th percentile. So you have to be careful there. Let's look at the next one. Those officers scoring below the 20th percentile are sent to undergo additional training. What is the minimum score needed to avoid this training? So now we're at the 20th percentile. Well, the 20th percentile falls lower than the 50th percentile, so we're somewhere over here on the left-hand side. This is a percentile at or below. So that represents the 20th percentile. So for this again, what we're going to do is we're going to take the inverse. I'm giving you a percentage. Inverse, and that's the normal. Give it a mean and a standard deviation. And this time, we're looking at notice here, you're looking at the left-hand tail area, which is already the 20th percentile, which is 20%. So we're going to type in 0.2. There is no need to flip this because we've already have the left-hand side. So when we type that in, functions, inverse, normal disk, 50, 10, comma, 0.2. I get a x value equal to 41.6. And notice that this value makes sense again because the 50th percentile is at 50. So we know we should get a value less than that. So make sure when you're doing this, you're calculating the correct side of the curve. It's always a left-hand tail, so you might need to flip numbers around. For instance, if we flip this number around, instead of doing 0.2, we do 0.8. Notice how it's 58.4, and that would fall somewhere over here, which would tell me I'm bigger than the 20th percentile.